We will be looking at the cosine law in this video. In the previous two videos we looked at the sine law and then the ambiguous case of the sine law, and there we were finding either sides or angles depending on the video. And in this video we will be begin our look here at the cosine law, and the cosine law is appropriate when you're given two sides, so say side A and C here, and the included angle for them, so the angle between the two sides. And that's what this is saying here. If we were using the sine law in this case, we would have to stop. We couldn't do anything because we'd be left with two variables. Remember, to apply the sine law, you needed at least one angle and the side that goes with it. So for example, this angle and this side. If you didn't at least have that, then you would have nowhere to go. So if we had this side and this side and this angle, we don't have an angle and a side that go together. So we couldn't use the sine law. When you have this situation, this is where the cosine law comes in. So I've written the cosine laws out here. Just realize you can find any side using the cosine law. You just rearrange the formula here around. And you'll need to pause the video and write these down if you don't already have them. So let's move on and work some examples. Okay, now for example 1, solve the triangle ABC where A is 5, C is 12, B is 28. So the first thing we'll do is sketch a triangle. We can shape this triangle just about any way we want as long as we label it correctly. I'm going to make it A, B, and C. Once I've established this, I have to fill in this information correctly. So A would be, side A is across from angle A, so this would be 5. Side C is across from angle C, so this would be 12. And angle B is 28 degrees. So we have an application of the sine law here because we're given two sides and their included angle. In other words, the angle between them. So this is appropriate to use the cosine law. So I'm going to paste in the form of the cosine law that we're using here. And we're going to be finding side B because we have the information to find side B. We have side A, we have side C, and we have angle B. So that's what we need to solve this. So if you notice, we can square root both sides and simplify this a little bit like this. And I'm going to fill in this information as we go. So A is 5, so 5 squared, plus C is 12, so 12 squared here, minus 2 times A is 5, times C is 12, times cosine of angle B is 28 degrees. So we'll pull up our calculator and enter that in. We'll make sure we're in degree mode when we do that. So let's put that in. Square root of 5 squared plus 12 squared, subtract 2 times 5 times 12 times cosine of 28 degrees. And we get side B is 7.94, so B equals 7.94. So we'll enter that information right here, 7.94. Actually, use another color that's a little hard to see, 7.94 for B. Okay, so now we just need to find side A and C. So now we're going to use the sine law to find our remaining sides here. So our remaining angles. Now we have this one angle, so we need these two. So we need to use the sine law, we need a complete pair. So we have this angle on this side. So we'll set up our ratio starting there. Sine of 28 degrees over 7.94 is equal to. Now we have an ambiguous case of the sine law because we're finding an angle with the sine law. So we need to be careful how we choose. The rule of thumb is as long as you choose the angle that goes with the smallest remaining side, you won't have to worry about that ambiguous case and having to use multiple triangles, etc. So I have a side of 12 and I have a side of 5. So I want to use this side. I want to use the shortest one because the sine law will give me an acute angle, and I know that the acute angle it gives me must go with this smallest side. Had I used this side, I wouldn't know if it was the angle that the calculator gives me or 180 minus that. So make sure that you pick the smallest side. So that would be sine of angle A over side A, 5. So we cross multiply, we get 7.94 sine of angle A equals 5 times sine of 28. So divide by 7.94, and we get sine of angle A is equal to that chunk there. So I'm going to back up a little bit, and we'll just do A is equal to sine inverse of this, 5 times sine 28 over 7.94. If you have trouble with the sine law, go back and watch those videos. So angle A is equal to this. Put this in our calculator, slide this over a little bit. So clear that out. Second inverse sine of, I'll use alpha y equals enter to put a fraction in here, 5 sine of 28 degrees in the numerator over 7.94, and we get 17.2 degrees. So angle A is 17.2 degrees. So that means that angle C is going to be 180 minus the other two. So 180 minus 28 minus 17.2. And angle C is 134.8. And we have this triangle solved. All right, example 2. Find the angles of the triangle whose sides are A equals 14, B equals 21, C equals 22. So they give me all three side lengths and no angles. So we can use the cosine law here as well. So we'll label this A, B, and C. Side A is 14, side B is 21, side C is 22. So it doesn't matter which angle I choose to find first. I'm going to choose to find angle B first, and that's fine. So if I paste in the, I'm using angle B here because I have the formula for it. If you notice, we have cosine of B in the formula here in the cosine law. So I'm just going to rearrange and isolate cosine B. So it becomes cosine B is equal to B squared minus A squared minus C squared all over negative 2AC. So all I did is I took the A squared over by subtracting it. I took the C squared over by subtracting it. That's where this numerator is coming from. And then because I'm multiplying cosine B by negative 2AC right here, I just divided by negative 2AC. And you end with this form here. So B, angle B is going to be equal to the inverse cosine of all of that. So B squared minus A squared minus C squared all over negative 2AC. So in our situation, that's going to be cosine inverse of B squared is 21 squared, subtract A squared is 14 squared, subtract C squared is 22 squared, all over negative 2 times A is 14 times C is 22. So we'll put that in our calculator, and that'll give us angle B. So let's use our fraction button here. Alpha y equals enter. Numerator 21 squared, subtract 14 squared. And then this was a subtract here. Subtract 22 squared, and that's all over negative 2 times 14 times 22. And I'll get that value, and then I should have done cosine inverse. I didn't type that in, so that's fine. We can do the cosine of the answer we just got there, and we get 67.2 degrees, and that was for angle B, so 67.2. So now I'm going to use the law of sines from here. After you use the law of cosines once, then you start using the law of sines. So I have one complete sine pair right here, so we'll start our ratio that way. Sine of 67.2 over 21 is equal to, okay, this is where you have to choose, and I want the smallest side. So I have 14 or 22 to choose from. I want to use the smallest side. So it would be sine of angle A over side A is 14. So cross multiply, we get 14 sine 67.2 is equal to 21 times sine of A. So divide by 21, we get sine of A is equal to 14 sine 67.2 all over 21. And that means that A is the sine inverse, the inverse sine of all of that, 14 sine 67.2 all over 21. So let's put that in our calculator. Second sine inverse of alpha y equals enter, put a fraction in there, 14 sine 67.2 degrees all over 21, and we get that angle is 37.9, and that was angle A, so 37.9. Now do 180, subtract 67.2, subtract 37.9, and we'll have this triangle solved, so 74.9. So we have all three sides, all three angles, and we are done with example 2. Now I know I went fairly quickly, especially on the law of sines part. You need to go back and watch those videos if you are still having trouble applying the law of sines. Alright, let's go on to the next example. Okay, in example 3 here it says use the parallelogram method to add these vectors, find both magnitude and direction of the resultant. So we'll make a parallelogram out of this, and it ends up looking like this. So we're going to find the magnitude and direction, so that'll be our resultant vector there. And if we apply some of our knowledge on parallelograms from geometry, this angle right here is the 40-degree angle. So this angle inside is 180 minus that, so 180 minus 40 is 180 minus 40 is 140 degrees. So now I'm going to sketch the triangle that we have. So we have the resultant R value here. We have our 24 length here, and we have our 18 length here. So I basically pulled this triangle out of that parallelogram. That's what I just pulled out. And we have our 140-degree angle right here. So we have an application of the law of cosines. We have two sides and the angle between them. So we'll be finding this side right here. So that's going to be r squared is equal to 24 squared plus 18 squared minus 2 times 24 times 18 times cosine of the angle 140 degrees. That's just applying the cosine law formula, so I'm going to paste that in so that you can see where that's coming from. Okay, so here is the formula here. So we are play like, for example, that this is this would be in the formula. This would be side B. This could be side A, and this could be side C. So all I did is fill that information in right here. That's all I did. Alright, so that means that our resultant is equal to the square root of all of that. So write it again, 24 squared plus 18 squared, subtract 2 times 24 times 18 times cosine of 140 degrees. Alright, so let's put that in our calculator and get the magnitude. So 24 squared plus 18 squared, subtract 2 times 24 times 18 times cosine of 140, and we get a magnitude of R. The resultant magnitude is 39.5 units. And now we need to find the angle, so we'll find this angle right here to give the direction of this resultant vector. That's appropriate because our vector is going in this direction based on the way we drew it. So we need the angle that gives its direction. You wouldn't want to find this angle because you want to find from the tail to the head, that angle. You don't want to find this angle here, and this angle has nothing to do with this particular vector. So with that said, we want this angle down in the corner, so we're going to use law of sines now. So we have a complete sine pair right here and here. We know this value of R right there, so we'll use that to our advantage. So we know that sine of 140 over 39.5, that's this angle on this side, is going to be equal to we'll just call our angle A here. So sine of angle A, that's our, actually let's use theta, that would be better. So I'm going to put our theta right here. That's the angle we're finding. Over its side length, which was this one, 18. So we cross multiply, and we're running out of room here. Scroll down a little bit. So we get 39.5 sine theta is equal to 18 sine of 140 degrees. So sine of theta is equal to 18 sine of 140 degrees, all divided by 39.5. So theta is equal to the inverse sine of all of that, 18 sine 140 all over 39.5. And once we have that, we'll have the problem done. Sine inverse, let's use our fraction button actually. Alpha y equals, enter 18 sine of 140 degrees over 39.5 gives us angle theta of 17.03 degrees. So theta equals 17.03 degrees. So we found the direction given by the angle 17.03 degrees. So that's part of our answer. And the resultant right here was 39.5. So those two pieces give us the answer to example 3, and that is it for this video.